I can't believe it either. We're already on lesson 18 and we've come a long way. We talked about destructive plate boundaries where plates collide, and now we're going to talk about divergent margins where the plates separate. And we've already talked about one type of divergent margin, and that's seafloor spreading. So we're already sort of experts on that. But just to refresh, that's where the oceanic crust spreads apart. And where it spreads is that cleft mid-ocean ridge where new volcanic upwelling rock from the upper mantle fills in the gap. And so that's the source of new crust on Earth. There are examples of this, well, in basically all of the oceans. Iceland is a unique example of a mid-ocean ridge because it's actually above the surface of the ocean and we can physically stand on it and look at it. Now the reason it's above the surface of the ocean is probably also to do with the fact that there's a big mantle plume underneath of it. And a mantle plume is just a very buoyant, hot upwelling of magma in the mantle, which would obviously push up the crust and release all sorts of masses, voluminous amounts of lava rather. Magma is underground. Lava is when it's extrusive and actually pours out at the surface. And that's exactly what happens in Iceland. It's a very volcanically active, geologically active place. And it's really interesting because in the west of Iceland, you're on the North American plate. In the east, you're on the Eurasian plate. And you can actually go and walk right on the plate boundary. And if you could wait hundreds of years, you could actually see it moving. So that's really interesting. The other type of constructive or divergent boundary occurs on continents, and that's called a continental rift. It's the opposite of a continental collision in that it's where a continent actually breaks up and a sea usually occurs there. If the continental rift is successful and it keeps rifting, it just turns into, well, ocean will fill in and you've just turned into seafloor spreading. So that's sort of how the cycle works. A modern example of this, and there are many geologic historical examples. You can look back through the rock record and find a bunch of successful and failed continental rifts. But one good modern example is the East African rift. And not surprisingly, that occurs on the east coast of Africa. And it goes right down the coast. There's a long depression. It's sort of an extensive valley. And on the edges, there's all sorts of faulting and volcanic activity. Some of the largest active volcanoes in the world are there, and some older ones like Mount Kilimanjaro. What's happening there is that the African plate is splitting apart, and it's also separating from the Arabian plate above. So it's actually not just a rift, but it's also known as a triple junction because generally just the continental crust is coming apart there. And will it be successful? Who knows? Wait around a few million years and we'll see. So why does this happen? Why would a continent just all of a sudden start to break apart and rift? Well, we know some of the reasons from seafloor spreading, and they're pretty much the same. So there's slab pull. So slab pull elsewhere might put strain on the continent. You could also have a convection cell in the upper mantle underneath the continent, and that would cause strain on it. There might be a mantle plume buoying up and sort of pushing up, causing upward pressure on the continental crust and causing it to want to come apart. And so those are all the same as seafloor spreading. The only other factor that I know of, and I'll mention it, but I'm not 100% sure on it, is a gravitational collapse. And what that means is if a continent has undergone a collision and it's sort of built itself up and elevated itself, there's then going to be a lot of downward pressure due to the force of gravity. It wants to sink back into the upper mantle. And that downward pressure also translates to outward pressure, causing it to rift apart. How much any one of those factors contributes, I don't know, and as far as I know, it's still under debate. But what's important to take away is that this is a common Earth process over geologic time. It's happened a number of times, and it's still going on. Now let's carry that thought to its extreme. We have all these continental rifts, we have seafloor spreading. So over geologic time, hundreds of millions of years, these continents and plates are moving around. Subduction is allowing them to keep going, and seafloor spreading is pushing the plates. So what happens when all these continents keep going around and around? Well, a traffic jam happens. You get sort of a continental traffic jam. And we basically call that a supercontinent, where you get a cluster of continents sort of huddling around semi-attached, or fully attached. The most recent supercontinent was Pangaea. Pan from the ancient Greek for entire, and Gaea comes from the ancient Greek Gaia, or Mother Earth. So entire Mother Earth is the derivation. So Pangaea was around 300 million years ago. And since then, it rifted apart, and the seafloor has spread, and very slowly, over these hundreds of millions of years, we end up with the continents in their current positions, as we see it on Google Earth or a map. Of course, plate movement is quite slow by human terms. Maybe in your lifetime, plates will move 5 to 10 meters. So really, it's barely noticeable on a human scale. But give it a few million years and we'll have to start changing our maps and atlases, because there'll be some significant changes. The Atlantic might get a little smaller, the Pacific will get a bit bigger, and the Mediterranean might start to close up. In 200 million years, if humans are still kicking about, well, then we'll have to make real changes to our maps, because the Atlantic will have all but disappeared. It might be an inland sea. The Pacific will be enormous. And North America and South America will have pushed right up against Africa. So this is what's predicted, and it's called Pangaea Ultima, and it'll likely be the next supercontinent. Just imagine that. If you live in North America now, you'll be able to take a scenic drive through the mountains into Africa. It'll be quite a different world. This brings us to the ultimate takeaway, and one of the main things I want you to get out of this course. The idea that terra firma, solid earth beneath our feet, is actually pretty much not the case at all. Even the steadiest of steady things, those rocks, the static, unchanging, rocky firmament, the stage on which we play out our existence, it too is impermanent. And just like all creatures and species, the earth takes part in this cycle of birth, death, and rebirth in a grand cycle.